batter walks up to the plate. There's routine in the action. Breathe. Shuffle the feet. Shuffle to do it. Get set, and the ball is released. There's no time to think, just swing. The sequence is repeated over and over again, but the window of opportunity stays constant. Once the swing is performed, each little transfer of energy is visibly represented in the net change of events. From the outside, it may look simple, but in that split second, quick adjustments are made in almost an instant. Force, speed, acceleration at play together. What we're watching is calculus at work. Baseball has developed an entire world of sports analysts behind the scenes, especially with swing optimization, team strategies, and technology. The first big step in this aspect of sports study is actually more in the realm of the ball. The spin rate, post-release grip, and rotational angle is measured in velocity and also through varying acceleration. The path of the pitch is entirely predictable and quantifiable. For this reason, studying it more intuitively not only teaches batters the nature of ball trajectory and how to hit it when faced with various pitch types, but it also serves as a helpful example for understanding how motion interacts with aerodynamic forces, which is beneficiary for external fields such as aerospace research. The math that is baked within pitching is more important because it forms the basis for why part of hitting relies on reaction and instinctual prediction, while the other part depends on repeatable swing mechanics, something close to second nature, but still requiring a deep comprehensive motion mathematics. The batter inputs his own velocity and acceleration in order to meet the ball on the plane. Being on plane is extremely important, and it's very backbone of what coaches aim to teach and what sports scientists aim to study. Boiled down to its core, and as stated before, your job as the batter is to have the bat travel through the window of contact parallel for as long as possible, essentially maximizing the buffer where you can be a little late or a little early and still hit the ball in the sweet spot and at a good angle to send it out of the park. On that note, home run hitting has increasingly changed the very essence of baseball strategy for offense. Similar to how modern basketball has evolved into a sharpshooting sport, baseball has evolved into a slugging-dominated one. Thanks to new technology, programs like StatCast and Google Cloud's AI assistants have developed insanely accurate and helpful data that is influential to understanding present and future innovation on swing technique. The data reflects a lot of what we see in calculus class. In a recent university study, researchers described the math and statistical backing of how previously players' average hitting angles were actually subpar to what the math deemed the optimal angle. Soon enough, the result of each new MLB season showed that more elevated baseball correlated to more runs generated and therefore more games won. Even more modern example of calculus at use, this time in the volumetric field, is the adoption of a new kind of bat. The torpedo bat, as it is named, exploded popularity in the 2025 season with its unique tapering end compared to the traditional barrel. The question is, how does this new type work, and why? Going back to Little League ball, players are taught the sweet spot of the bat, the area where the energy transfer is at a maximum. The torpedo bat fixes that problem that calculus can pinpoint. The center of the mass is distributed closer to the hands, resulting in a stronger and easier transfer of rotational energy. The other benefit that the bat provides is the volume decrease of up to 25% compared to the original. It was found that it was more common that players would hit the ball lower than the original sweet spot, so it only made sense that the sweet spot be maximized to the most common area of contact, and along with that, reducing the overall weight of the bat. A single swing isn't only about movement. It requires making the right decision, which depends on when to move and what's happening on the field. Calculus allows us to understand what happens, showing us every shift on any curve on its graph. Now, a large number of people are learning to use the tools that were once unknown, and baseball coaches are paying more attention to the details. While mastering the swing, players practice ways to advance, change, and progress. This covers way more than just hitting. The goal is to move first to understand change, and then to use that new knowledge to improve. Because of that, attitude, learning, innovating, and progressing are taking on new forms, both on the field and around the world.